Hello, I'm Mark Gilbert. Welcome to C# Design Pattern State. State is one of those concepts that's so ubiquitous and intuitive that we seldom have to think about it. So before diving in, let's take a look at exactly what we mean when using the term state. At its most basic, state can be defined as the condition of something variable. It's important to note that the term variable here is being used in its common linguistic sense, something changeable, and not referring to variables used in computer science or mathematics. At some point early in our educations, we were all introduced to the common states of matter: solid, liquid, and gas. And we learned that the same substance can have different properties and behaviors based on its state. Water flows, steam rises, you get the picture. But we don't have to go back that far. You're taking this course on some form of device, and that device needs to be connected to the internet in order for you to access this content. Taking the exact same steps you took to get here on a disconnected device would result in some form of error. Another way to put this is to say that your device can either be in a connected or disconnected state, and your device will behave differently based on that state, either serving up content or displaying an error. As developers, we face questions of state all the time. Let's say we're working on an order processing application. Is an order new, processing, canceled, or complete? And we implement behaviors based on these states. Can a user edit a canceled order, or can a completed order be canceled? This is just one example. The types of objects in an application and their behaviors are virtually unlimited, but regardless of the type of application you're developing, you'll invariably face questions of state. During this course, you'll be introduced to and implement a tried and true design pattern to apply to these challenges, the state pattern. The state design pattern is one of 23 design patterns documented by the Gang of Four that describes how to solve recurring design challenges. Specifically, it addresses how an object can change its behavior when its internal state changes, and how state-specific behaviors can be defined so that new states can be added without altering the behavior of existing states. These are fairly high-level challenges, and it's difficult, based on these words alone, to see how solving them can benefit a real-world application. Throughout this course, we'll be working with a demo project. The project models a simplified event booking application that allows users to register for and book a single upcoming event, and simulates some of the behaviors you'd expect from this type of system, like the creation of bookings, their submission, cancellation, processing, and expiration. We'll begin implementing these behaviors in what we'll call an intuitive or naive approach, in other words, without implementing the state pattern, and fairly quickly encounter challenges related to state. With this concrete example in hand, we'll relate these challenges to the design challenges the state pattern was developed to overcome. Then, with a firm grasp of these problems, we'll dig into the state pattern itself, first from a conceptual level, then by getting hands-on, implementing the pattern in our demo application, and exploring the benefits. In the next clip, you'll be introduced to the demo project that you'll be using throughout this course.